Okay, so we've talked about the data, trillions of tokens of internet text, and we have talked about the game, predict the next word over and over. But we haven't answered a pretty basic question. What is the model? If you could open up a model and look inside, what would you see? Here's the answer. It's a mathematical function. That's it. A really big mathematical function. Numbers go in, numbers come out. You feed it a sequence of numbers, those token IDs we talked about. And it spits out another set of numbers, the probabilities for what word comes next. Everything in between, math, additions, multiplications, and a few other operations done billions of times over. No magic, no secret sauce, just math. Now that big box in the middle, the mathematical function, is what we call a neural network. Let's understand this function with the help of an analogy. Imagine a massive factory, and inside this factory there are billions of tiny dials. Each dial can be turned a little to the left or a little to the right, and each dial controls one tiny decision within the overall calculation. One dial might control something like when the word not appears before good, how much should that flip the meaning? Another dial might influence when the text looks like a news article, how much more likely should formal words be? Another one might handle when doctor appears before a name, is the next word more likely to be a surname? No single dial does anything impressive on its own, but billions of them working together, each making one micro adjustment to the calculation, that's what produces the output. These dials have a technical name. They're called parameters or weights, and the number of parameters is one of the main ways people measure how big a model is. GPT-3, which was released back in 2022 and was considered mind-blowing at the time, had 175 billion parameters. 175 billion dials, each one carefully set to a specific value. To give you a sense of scale, if you wrote down every single parameter on a piece of paper, one number per line, you'd need a stack of paper that would reach from here to the moon and back several times over. Modern frontier models are thought to have trillions of parameters. The exact numbers aren't revealed, but the trend is clear. Bigger models with more dials tend to perform better. Now here's the natural question. Who sets all these dials? And the answer is nobody. No human being sits there and tunes 175 billion dials by hand. That would be insane. The dials are set by the training process. Remember the game from before? Hide a word, guess, check how wrong you were, adjust. That adjust step, that's the step where the dials get turned a tiny bit billions of times until the model gets good at predicting. We'll get into exactly how that adjustment works in a moment, but for now, the important thing is this. The values of those parameters, those billions of specific numbers, are the model. When you download an open source AI model, you're literally downloading a file full of numbers. That's what it is. A list of very precisely tuned numbers and a recipe for how to run calculations with them. Here's a way to picture it. An LLM is like a zip file of the internet, but an imperfect one. Think about what happened during training. The model saw trillions of tokens of text, books, articles, conversations, code, and all of that got compressed down into, say, 175 billion numbers. That's the zip file. But here's the thing, 175 billion numbers, as big as that sounds, is nowhere near enough to store trillions of tokens perfectly. It's like trying to squeeze an entire library into a single notebook. Something has to be lost. So the model doesn't memorize, it can't, it doesn't have the space. Instead, it does something much more interesting. It extracts patterns, it keeps the general structure, the recurring themes, the rules of language, the relationships between concepts, and it lets go of the specific details. That's why an LLM can tell you that Paris is the capital of France. That pattern was so strong and so common in the training data that it survived the compression. But it might get a very specific, obscure fact wrong because that detail didn't make it through. Like if you ask it, what year did this tiny village in rural France change its mayor? It might give you a confident sounding answer that's completely made up. The pattern of villages have mayors who change periodically survive the compression just fine. The specific detail of which year, that was too rare, too niche, it got lost. It's not remembering, it's reconstructing from compressed patterns. Like how you might remember the plot of a movie you saw years ago. You're not replaying the film in your head frame by frame, you've compressed it into the key beats and you're reconstructing the rest. Sometimes you get a detail wrong. That's exactly what LLMs do. And this, by the way, is why they hallucinate, why they sometimes state things confidently that are just flat out wrong. They're not lying, they're not making things up on purpose, they are reconstructing from a lossy compression, and sometimes the reconstruction fills in a gap with something plausible but false. So, to recap, the model is a giant mathematical function with billions of tuned parameters. Those parameters are a compressed, imperfect representation of all the text the model was trained on. Numbers go in, numbers come out, and in between, billions of tiny dials shape the calculation. But we've been hand-waving something important. We keep saying the dials get adjusted during training. How? How does the model figure out which of those 175 billion dials to turn and by how much? That's the next piece of the puzzle.